All right, ladies and gentlemen, sorry for that. um, Today, we're going to get started with our chemistry class. And today we're going to get started on talking about the atom. Now, more than talking about the structure of the atom, which we all know, we're going to talk a little bit about the theories that led to the development of the atom or the atomic theory. So let me start sharing my whiteboard for a minute with you guys, and we can start talking about the atomic theory or the development of the atomic theory. More importantly, we're going to talk about the philosophical development of the theory, and we're going to talk a little bit about the Dalton atomic theory. So the first thing that I want you guys to know is that the idea of the atomic theory started about 400 years BC. So the idea of the atomic theory started about 400 years BC. Okay, so this is not necessarily a new theory. It's been hype. It's been theorized for certain years, for centuries. Excuse me, and one of the first people to theorize this was Democritus, which is a Greek philosopher. And Democritus, and let me see if I can spell this correctly. Democritus. Was Democritus. Democritus was the first known philosopher. I'm pretty sure he wasn't the only one, but he's the one that's documented as um, calling nature's basic particle the atom. Okay, so he was the first person, the first documented person to call nature's basic particle the atom. And the word atom comes from the Greek um, word which means indivisible. Meaning indivisible. Okay, so I'm actually going to read from your book. It says the particle theory of matter was supported as early as 400 years BC by certain Greek thinkers such as Democritus. He called nature's basic particle an atom based on the Greek word meaning indivisible. Aristotle, which is another Greek philosopher, um, he did not believe in the atom. Okay, so you had Democritus who called nature's basic particle the atom. Excuse me again. And then you have Aristotle. Now, Aristotle was another Greek philosopher. Um, and he did not believe in the atom. So Dalton, I'm sorry, not Dalton, excuse me, Democritus was the first person to coin the word atom. Um, and atom means indivisible. But then Aristotle basically said that he didn't believe in the atom. And Aristotle believed that all matter was continuous. That all matter was continuous. Okay, so here we have two philosophers who had different views on the atom. First of all, the atomic theory was theorized as early as 400 years BC by Democritus, and then um, Democritus was the first person to call nature's basic particle the atom, which means indivisible. And then Aristotle, who succeeded Democritus in his thinking, he said, no, 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 I don't believe that matter is indivisible. I believe that matter is continuous. So he went against what Democritus had early established, but it's very good to understand that neither Democritus nor Aristotle's idea were supported by experimentation. Okay, so none of these ideas were supported by experimentation. The Greek philosophers made many great contributions to learning and to society and all these things. In fact, Aristotle's ideas are very widely accepted in Western philosophy, but their ideas were not supported necessarily by scientific experimentation or evidence. Now, um it wasn't until the late 1700s that these ideas started to kind of be said, well, maybe they were not right. And a lot of scientists began to experiment. And it was with the development of machines such as the printing press, where reading became more accessible to people, where scientists then began to question these ideas that were established so many years ago by the Greek philosophers. In fact, basically, or virtually, or almost all chemists by the late 1700s um, accepted that an element was a substance that could not be broken down into smaller, components. So basically, it was um, by the 1700s, all chemists pretty much believe that, but there were things that still were kind of up in the air, and they were trying to see what they could do, right? So let's talk real quick about some of the things that were later discovered. So, through experimentation, through various forms, and a lot of great contributions by scientists at the time, three concepts came to be. Now, the first concept was the law of conservation of matter, and let me define that real quick. The law of conservation of matter states that mass is neither created nor destroyed. Mass is neither created nor destroyed. Ordinary chemical react and nor destroyed, excuse me, during chemical and physical. or not just chemical, during ordinary. It's very important that we stress that ordinary because, of course, we have particle accelerators and all these other things. Chemical and physical actions. So the law of conservation of matter says, hey, you can't just create or destroy matter. You can't create nor destroy matter in a chemical reaction. All that happens is that, at least in an ordinary chemical reaction. Okay, so basically what it's saying is that matter in the side of a chemical or physical reaction conserves itself. It does not change. You can't create it and you can't destroy it. And that led to the law of definite proportions. So let's talk about the law of definite proportions. The law of definite proportions, definite proportions states that um, I'm sorry, that a chemical compound contains the same elements, contains the same elements in exactly the same proportion the same proportion by mass regardless of the size. And what that means, guys, is pretty much that. And I'm going to erase this real quick. If you guys have any doubts, you can always pause and rewind the video and read that. Basically, what the law of definite proportions says, that it doesn't matter if I have a drop of water or if I have an ocean full of water or a river full of water. The proportion of the water molecule is always going to be the same. And the other thing that was established was the law of multiple proportions, okay? Which basically, the law of multiple proportions states the law of multiple proportions, excuse me, states the law of multiple proportions states that if two or more different compounds, that if two or more different compounds two or more different compounds of the same two elements of the same two elements if two or more different compounds of the same two elements, I'm sorry, two or more different compounds are compounds. Let me fix that. Are compounds. Let me write that here. Are compounds of the same two elements. I just realized I wrote the same thing twice. If two or more compounds of the same two elements, excuse me, of the same two elements are composed. You see? Are composed. Sorry, guys. Are composed of the same two elements. Of the same two elements. The second element combined with a certain mass of the first element is always a ratio of small whole numbers. It's composed of the same two elements. The ratio masses of the second element of the same two elements combined the second element, combined with certain mass of the first element will result in a ratio of small whole numbers. For example, what that means is that water, for example, will always have a 2-to-1 ratio over oxygen. It just means that I'm sorry, not water. It means that, for example, hydrogen will always have a 2-to-1 ratio over oxygen. It just means that there's always going to be, for example, let me write that down. Hydrogen will have 2 molecules versus 1 oxygen molecule. That's what that law states. That, if you have water and that water has a lot of like or excuse me, if you have molecules, a compound of water, which is of course made of oxygen and hydrogen, that law states that pretty much for every molecule of water, there's going to be 2 hydrogen molecules versus 1 oxygen molecule. So that's pretty much what it means. It's just that it's very explained in a very complex way. Okay, so the law of definite proportion states that elements that are composed of two or more, or compounds that are composed of two or more of the same elements, will always be present in small whole number ratios. The law of conservation of matter says that in the ordinary chemical and physical reaction, matter cannot be created nor destroyed. And the law of definite proportion states that compounds contain the same elements, or contain the same elements in exactly the same proportion throughout. And that means that a drop of water or an ocean filled of water will always have the same proportion of the elements that combine it or compose it. So let's continue on with Dalton's theory. Now I'm going to summarize Dalton's theory a little bit. I'm not going to go in depth to it as in your textbooks. If you have any questions with it, you can always make reference to your textbook. Specifically, I believe it's on page 64. There are 5 points. So Charles Dalton was an English school teacher. Okay, so that's good to know. Charles Dalton. I'm sorry, I'm not Charles Dalton. John Dalton. I'm thinking of Charles Darwin. John Dalton was an English school teacher who proposed the first, or one of the first, or let's just leave it at that, who proposed an explanation for all these laws. An explanation for these laws in 1808. So what Dalton did, 1808, I'm sorry. So basically what Dalton did was he pretty much said, well, this is why matter conserves itself, or this is why there's a definite law of proportions, or this is why there's a law of multiple proportions. He basically gave the reasons as to one. And the first thing that he says that all matter is composed of atoms. He said all matter is composed of atoms. The second thing that Dalton said is that atoms of an element are identical in size and mass. He said that atoms of an element are identical in size and mass. In size, mass, and other properties, excuse me, and other properties, size, mass, and other properties, atoms of different elements differ, and that of different elements, that atoms of different elements, and that atoms of different elements differ in size, mass, and other properties. Basically, what that means is that he said, well, all hydrogen atoms have the same traits, but all hydrogen atoms are different than carbon atoms. So that's pretty much what he was saying when he was explaining that. He said the third thing that he says that atoms cannot be subdivided, created, or destroyed. Or destroyed. So basically, he's saying that atoms can't be subdivided, they can't be created, they can't be destroyed. Partially true, atoms cannot be created or destroyed, but as we will later find out, they can be subdivided. And it says that atoms of different elements combine in simple whole number ratios. Atoms of different elements combine in simple whole number ratios, in simple whole number ratios to form chemical compounds. And the last thing that he said is that in chemical reactions, atoms are combined, separated. Atoms are combined, separated, and rearranged. Okay? So basically, Dalton's theory, which is this, explains the law of conservation of matter or conservations of mass. And basically by saying that atoms combine, separate, or rearrange themselves. I'm actually going to read from the book. It says Dalton's atomic theory explains the law of conservation of mass through the concept that chemical reactions involve merely the combination, separation, or rearrangement of atoms, and that during reactions, atoms are not subdivided, created, nor destroyed. So basically, and if I go in, it's actually in this point, give me a second, let me separate this a little bit more. So it's basically in this last point. in the last point that says that in chemical reactions, atoms are combined, separated, and rearranged. And in the third point that says that atoms cannot be created nor destroyed in a reaction, that those 2 points or the combination of those two things help describe the law of conservation of mass. Vamos a seguir entonces, or let's continue, guys. Excuse me for the Spanglish there. Let's continue then to talk about the importance of Dalton's atomic theory. Basically, Dalton's atomic theory explains the law of definite proportion, that the law of definite proportion results from the fact that a given chemical compound always contains the same combination of atoms. So we know that the law of mass is explained because atoms in chemical reactions are rearranged, separated, combined, and atoms cannot be created nor destroyed in a chemical reaction. And it's this point right here that says that atoms of different, and I just realized that I did not write of, I wrote OD. This point right here, the atoms of different elements combine in simple whole number ratios to form chemical compounds. That one explains the law of definite proportions simply by stating that if I have, and I use the water example because it's a very common one, that I have 2 hydrogen molecules for every 1 oxygen molecule, that explains the law of definite proportions. Or if I talk about carbon dioxide, where 2 oxygen molecules formed are present for every 1 carbon molecule. So that pretty much explains the law of definite proportions. And of course, and I read from your book, it says the law of definite proportions results from the fact that a given chemical compound always contains the same amount of atoms. So the law of definite proportions, basically from this point that all matter, the atoms of elements are identical in size and mass and other properties. Basically, this is the one that is telling us that it doesn't matter if I have a drop of water or if I have an ocean full of water. That is going to be true. It's right here. It says atoms of elements are identical in size, mass, and other properties, and that atoms of different elements differ in size, mass, and other properties. So basically, it's saying that it doesn't matter if I have a drop of water or an ocean full of water, it's going to have the same proportion. And lastly, the law of multiple proportions is explained by the fact that elements um, that atoms of different elements combine in simple whole number ratios to form chemical compounds. So again, this one specifically talks about the law of multiple proportions right here. Okay, I'm going to highlight it real quick. This one right here talks about the law of multiple proportions, which says that atoms of different elements combine in small whole number ratios to form chemical compounds. For example, you will always have 2 oxygen molecules for every carbon molecule. So you'll always have 2 oxygen molecules for every carbon molecule. And that's an example of the law of multiple proportions. And it's this law right here that actually talks about the law of right here. Let me see if I can. Is this one right here? Atoms of different element are identical in size, mass. It's this one and other properties. This one is the one that talks about the law of definite proportions. Okay. Because it's saying that atoms are going to be arranged in the same proportion, no matter if it's an ocean or no matter if it's a drop of water. So that's very important. And lastly, let's talk about 2 important things that or the important concepts of Dalton's theory. Here's one thing. So, Dalton's atomic theory is still widely accepted, but here's one thing. So, Dalton's theory is not discarded, it has been modified. And one of the modifications is the fact that atoms can be subdivided and have been subdivided such as protons such into has been subdivided into protons, electrons, and neutrons. So it has been modified. It has been modified because now we know that atoms can in fact be subdivided. And the important concepts that we kept from Dalton's theory, or concepts that are still relevant, concepts that are still relevant in Dalton's theory is that all matter is composed of atoms. 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 And that atoms of any element differ in properties, and that atoms of different elements, or atoms of any one element, atoms of any one element differs in properties from atoms of another element. Atoms of another element. It says atoms of any one element differ in properties from other atoms of another element remain unchanged. Basically saying that the two things that are still relevant in Dalton's theory today is that all matter is composed of atoms, and that atoms of one element different properties from atoms of another element. That's basically what it's saying. You know what? Let me delete this part. I think this part makes it easier to understand. So those are the two theories that are still relevant in Dalton's theory, and Dalton's theory is still accepted. It's just that it's been modified. But the concepts that still remain the same are one, that all matter is composed of atoms, and two, that atoms of any one element different properties from atoms of another element. So guys, I hope that this video was helpful. And if you have any doubts, you know where to find me. So stay safe, and we'll see each other in our next class. Bye.